meeting was going on. Sorry for the delay. Give me 2 minutes. Let me open my PPTs and all. Then we will start. Okay. Okay. So I will share the screen. Wait. Yeah. So in the last class, if you remember, we talked about the bubble sort and the concept of the sorting. What basically sorting says is what we want in sorting is we want to arrange the numbers in the ascending order. Okay, so in this case, if you see in the bubble sort, what we were doing, if I go to uh, last day's PPT, so if you remember this one, what we were doing, we were taking alternate two in elements and we were comparing those elements and we were arranging them in ascending order. Two elements were arranged in ascending order. Okay, so in that case, when two elements are selected and they are arranged in incremental order, what will happen at the end of the first iteration? You will get the last element as the largest element of that array. So what you will do, you will arrange them, bring the last element to the end. Now freeze that component. So how to freeze that component? So you will you will remove that element from your for loop simply. So earlier it was up to say n minus 1. N minus 1, why? Because if n is a number of elements, then if wait, if n is, say, in this case it was 1 2 3 4 5 6 7 8. So we are having indexes from, index will be from 0 to 7. Okay, so 7, seventh index is having the largest value. Now what you will do in the next iteration, if I talk about round 2, what you will do in round 2 is you will remove this element from the iteration. So now your for loop will run from 0 to 6 instead of 7. So automatically this one is frozen. Last 98 is frozen. The same thing is to be repeated after the round 2. Now what you will do, you will freeze the last two values. So these two values will be frozen. And if these two values are to be frozen in the next iteration, what you will do, you will reduce your for loop from 0 to 5 now. And this way you will go on reducing the value of the for loop, and definitely at the end of the n number of n minus 1 number of iterations, you will get the sorted array. This was the method what we used here. Now, if we talk about insertion sort, as I said, the same thing can be done in a number of ways. A number of ways means what? If you remember the example that I have taken, we are having 8 rooms. Students with different roll numbers are sitting in different rooms. They want to arrange themselves in the ascending order, means the person with the lowest roll number should be sitting in the first row, and so on. This is to be done. So they can do this thing multiple number of ways, in a number of ways. Uh, they can send the input to one can sort them, and one can instruct everybody where to go. Okay, or the way around, as we have done in the case of bubble sort, the two neighbors can mutually uh, define which one is larger, and they can interchange their room, and this way the last room will be occupied with the largest roll number, and so on. So in this case, in insertion sort, what we are doing, in the case of insertion sort, we are arranging this thing as two different arrays. One is the sorted part and other one is the unsorted part. So the first element is considered to be the sorted one, and we define the rest of the elements as the unsorted one. Now what we have to do is, what we will do in the next case, in the from the unsorted array, if you see, uh, we will take the next element, second element, and see whether this element is greater than the first element or not. Yes, it is greater, so it will be placed here only. Now what we have to do is we have to insert them. It is something like this. All 8 rooms are there, or instead of 8 rooms you can think about 8 seats. So first one sat here. Okay, then 12 came, so 12 is having higher value than 5, then 12 sits here. Then next one is 87 having higher value, so sits here. Then comes 25. So 25 comes and asks them, what's your number? This one says 87, this one says 12. So what 25 will say? I want a space in between both of you. So what this one has to say? This one will shift here. So this one will be removed. What will be entered here? 25 will be entered here. Now what will come? 9. So 9 will search for this place where 9 is to be stored. So 9 will come over here and say, okay, I want a space between 5 and 12. So what is to be done? Shift everyone to the right. So what will happen? 12 will move here, 25 will move here, 87 will move here. So a space is created, so 9 will be stored here. Then 65 comes. Then what will happen? 65 is to be stored between these two. So a space is to be created here and 65 will be stored in between. So basically what they're doing, they're inserting each value at the right location. Take one value and insert it at the right location. Okay. Somebody's mic is on. So this way we go on entering the values or inserting the values at the proper location, and that's why this one is known as insertion sort. If you see step by step, in the first step, 5 is considered as sorted. Then a new member comes, 12. Now you will see whether 12 is greater than 5 or less than 5. If it is greater than 5, then it has to remain at the same location. And now we will call this part as the sorted array, right? And this part as the unsorted array. Now, what will happen in the next step? Next value will come. What is the next value? 87 is there. Then 87 is also at the proper location because 87 is greater than 12 and already we have sorted this one. So if it is greater than 12, this means that all three are sorted and these are unsorted. Now 25. What is to be done? 25 is to be placed in between 12 and 87. If you see, between 12 and 87, here is space is required. What 87 will have to do? 87 will have to move to right. So 87 will move to right and 25 will come here. So 25 is inserted here. Then there is a requirement for a space for 9 in between 5 and 12. So how this thing we will know where to place 9? 9 will be compared with each and every element. So it will be compared with 87, whether it is Greater than 87? No. Whether it is greater than 25? No. Whether it is greater than 12? No. Whether it is greater than 5? Yes. So it has to be inserted on the right side of 5, right? Because we are having all these elements in sorted form. So just by comparing with each element, whether it is greater or not, we can identify where this one needs to be placed. So yes, now this can be placed over here, right? So next comes 65, where it will be compared with 87. Whether it is greater than 87? No. Whether it is greater than 25? Yes. So 87 is to be moved here and 25 is to be moved here. So now 65 comes over here. This way, now if we consider 98, 98 is greater than 87, so it will remain at the same place. Then 34. 34 will be compared with 97. Whether less than 97, greater than 97, no. Greater than 87, no. Greater than 65, no. Greater than 25, yes. So it needs to be placed here, right? So what will happen? 65 will go here, 87 will go here, 97 will go here, and 34 will come here in between. So this one. If you see this array, then it is a sorted array, as you can see, right? So this way we are having the insertion sort, where we are sorting all the values. In how many steps we have done? 1, 2, 3, 4, 5, 6, 7, and 8. Eighth one is basically the sorted one. So in 7 steps, we were able to solve this thing. For how many elements? For 8 elements. Okay, so n minus 1 iterations are required. In the earlier case, if you remember, we were having n minus 1 iterations, but each iteration was having certain comparisons, right? So every 2 elements were compared in each iteration. So definitely in this case, less number of we can say computations are required. But in this case, if you see it carefully, it is not that easy as it appears, because in this case, 3 things to be done. First thing is to compare this value, the first value, with this value. So this is one aspect. If this 25 is to be inserted in between 87 and 12, then first of all, 25 is to be compared with each element. Find out the index where the comparison is successful. Comparison is successful means 25 is greater than that element. And then third thing to be done is moving these elements to the other position. So 3 things are to be done in this case for getting the result, appropriate result, right? So if we go to the algorithm for this, I will pause for 30 seconds, then then we will discuss what is written over here. Okay, so now I think you have read it. So basically what this one is doing, we have initialized the value of I to 1, right? Then we are saying that repeat this 3 to 6 part when I is less than n. Less than n means number of elements. Okay, so here we are talking about basically for loop running from 0 to n minus 1, right? So it is that thing. But why we are not taking 0? Because the first element is already considered to be the sorted one. So we will start comparison with 1 only. So if this is the array, say we are having 3, 4, 2, 1, these are the four values. So this one is initially considered sorted. What you will do is start with 4 and compare it with 3. Okay, so you will always start with index 1, not with index 0. So this is to be taken care of, right? So you will start with index 1 and you will go up to n minus 1. So this is what this statement says. Now what they did, they took the value of ai, means 4, in temp. They took one variable temp and stored the value of ai, that is 4, right? Now they are setting the value of j as I minus 1. So here they are talking about comparisons to be done. Repeat step A and B while temp is less than AJ. What you have to do? If 3 is less than 4, then in that case you have to do this thing. What is to be done? If 3 is less than 4, set AJ, sorry, temp is less than AJ. In this case, temp is greater than AJ, so it won't go in this loop. But if this, say this value is 2, right? So in this case, yes, temp means, then in that case, this will have 2. Now 2 is less than 3. So what is to be done? You have to swap the values. So for that, what they are doing, shift this value. Already 2 is in temp. So what you do, you shift 3 to this place. So now 2 is deleted. That's why we have already taken it in temp, because this value will be deleted from here. Okay. So 2 is already in temp. Now what is to be done? You have to reduce the value of j. Why to reduce the value of j? For this thing, I will tell you. This is, say, 7, this is 3, this is 2, this is 1, and this is 8. So in the first case, what is to be done? 3 is less than 7. So what you want is, take 3 to 10 and shift 7 to index 1. So basically what you will be doing, you will be removing this 3 and you are putting 7 here, right? Now what is to be done in the next phase? So basically, if you see what is there, this is 7, this is 2, this is 1, and this is 8. And what you are doing here, you are putting the value of temp here, right? So 3 and 7 are done. This is fine when you are having two elements. Now, if I talk about 2, so 2 is to be placed here. So again, what you will do, you will put new temp as 2. Now, what is to be done? What you have to do, you have to change the value of 3 to 7, and 7 is to be done to 2. Okay, so you have to shift two values. So for that we are using j minus 1, so that all the values may be shifted as per the requirement. In this way, in this case, one value was required to be shifted. In this case, two values will be required to shifted. In the third case, when you will have take temp as 1, three values will be required to be shifted. So for that we are taking this j is equal to j minus 1, right? And finally what you're doing, after shifting the values, you are sending that value of temp to the space which is created, and then we are incrementing the value of I, and then it ends the steps. If we go to, I think this thing is clear to everybody. If you have doubt in this sort, then you can ask. If I actually go to the code, wait, if I am, actually, I have not started Devdi CPP. Let me start it. If I am having the code, I will show you the results. Yes, I will repeat that code part. Yeah, I'm having it. Sharing you the screen so that that code is visible. I hope this code is visible now. Basically, I will repeat what I explained, just explained. We have three things to be done in this insertion sort. Why I am explaining you the three different things in case of bubble sorts, insertion sort, because if a question comes where you are not directly required to use insertion sort or bubble sort, but you are required to do something like sorting in some other way, then you should be able to use that module, what this module is doing. So one module is doing what one module is doing. One module is identifying whether the value is less than the newcomer or not. Number one. Number two, second module is identifying the place where it is to be inserted, right? And number three, for creating the space, what you will have to do, you will have to shift the values by one, all the rest of the values by one. Okay, so this is the third module, right? If we talk about this algorithm or this code, how these three things are done. Here is the reading part and all. I will skip this part. Once you have all the elements in the array, what you are doing here, in this case, if you see, this one is going from I is equal to 1 to I is less than count. Count is the number of elements here, right? If I am inserting 8 elements, then it will go from 1 to 7, right? Why 1 to 7? Because if I talk about the first element, that is index 0 element, what we are considering initially is that first element is already sorted. So we are starting with one. So comparison with will be between the sorted one and the unsorted one. So the comparison will be between the first element and the second element. So that's why this for loop is starting with one. If you start it with zero, what will happen? You will not be having I minus one value, and so you will land in error, right? So that's why we are starting it with one. Now what we are doing, we are putting the value which is to be compared in temp. The value that needs to be inserted is put in temp. Why it is kept in temp? Because now we will check whether this value is greater than the all the sorted values or not, and where it is to be placed. These two things we have to identify, right? So now for comparing it with all the values, what we are doing is we are comparing them with the values here, and we are also checking it should not go beyond 0. J should not go beyond 0 because after 0, you're not having any values, right? So it should go up to 0 only. So this is for boundary checking, right? It should not go unbounded. And this part is for comparison of the values. So when you go on comparing, as soon as this condition is true, what you have to do? You have to shift the values to the right. Start shifting the values to the right. If you remember, I showed this thing. That, for example, in this case, 4, we are comparing 3 and 4, right? So 3 we have skipped as A0, and this one here we are starting. So what we did, we placed this 4 in temp. So temp is now having 4. Then what we did, we compared 4, that is your temp, with each and every value of the sorted array. So when we compared 4 with 3, so 4 is not lesser than 3, right? So the while loop is false in this case. So no while loop will run. Now what will happen? You will enter the new temp value as 2. Now what you will do? Temp value is 2. You will have to compare 2 with 4. So 2 is less than 4. Yes, true, it is less than 4. So what needs to be done? You have to shift these values from these location, and you have to create a vacant space for 2. So basically what is to be done here is something like this. This goes to temp, so temp is having 2. Here also it is 2 right now. So now what you want to do is you want to shift this 4 here. So this will be removed, 4 will come here. This 2, this place, so 4 will be removed, 3 will come here. And now you want to insert this 2 here. This is what is to be done. So how we are doing this thing is, wait, yeah. How this thing is being done is this part. This is shifting the values to the next place. J plus 1 means next place. What you're doing, you're sending the value from the last place to the next place in this. And this is to be done for all the values till the value is reaches 0. So you will go on shifting all the values by doing j minus 1. Not only one value is to be shifted, you have to shift all the values. And once all the values have been shifted, next what is to be done? Now you have created the space. So you place the value which is stored in temp in that place, right? And simply print the result. This is how this function is going to work. How many numbers you want to enter? 5 numbers. What are the values? So I will enter the values in reverse order. And the sorted elements are 1, 2, 3, 4, and 5. Right? So what insertion sort is basically doing? Insertion sort is basically, moment please. Insertion sort is basically inserting the values at the proper location. So we will go to the next sorting algorithm, that is the selection sort. What selection sort is doing is something like insertion sort, but what they are doing is they consider the first element as sorted. Now what they do, in the unsorted array, they identify the least value or the smallest value. So 2 is the smallest value in this array. So what they will do, they will swap these two values. Bring 5 here and bring 2 here. Now what will happen? This part is sorted. 2 is the least value. Now this is the unsorted part with 5 here. Now again they will identify the least value and they will swap with the next value. So 5 will come here. So this is the sorted part and this is the unsorted part. Then again 12 comes here. They will identify the least value as 8. They will swap it with 12. So basically what they are doing two things. One is identification of the least value in the array, and second one is sorting it with the next or the first unsorted value. If you see where we are sorting it with the first unsorted value. So in this case, if you see first unsorted value after this 5 is done, 2 is comes here, the next unsorted value is 12, right? So what it will do, it will swap the first unsorted value with the least value. So the unsorted value will have the second value and this will the sorted one. So this way they are shifting the first unsorted value with swapping the first unsorted value with the least value. And this way they will go on arranging the values and finally we will have the sorted array. If we go with the part how it will be done, so basically what we will do, we will compare and find out the minimum value and the index of the minimum value. Now simply what you will do, you have the index of the one which is the first unsorted one, so you will take that index and you will run a program for swapping. So this is the part for swapping and this is for identification of minimum value. Okay. So what you will do, you will swap the values using a third variable, temp variable. You can do it without using the temp variable as well. Here we have used, so temp is equal to AI, POS value as AI, and temp as POS. So basically the values have been swapped. And this process should continue from where to where? It will start from 0 index to n minus 1 index. So n minus 1 number of times, sorry, not from 0 index, from 1 index, right? It will run and the sorting will be done. Again, I will pause for a minute. You read the algorithm and then we will discuss. Okay. What this means is, see the steps, what needs to be done. So if we start with I is equal to 1, it will start as in the last case, and we are repeating this part. What needs to be repeated? Initially, we are taking the value of min as the first value, and now and we are setting the flag as 0. Now we are comparing the values, all the values, next values. First value is the min value, but we are comparing all the next values. For example, if I am having this as the array 4 1 3 2, so we will compare all the values and find out the minimum. So 1 is the minimum. So what is done over here is finding out the min value in min and finding out the index of min in POS. And if you have some minimum value, then you will set the flag as 1. Because if flag is 1, then only we are going to swap the values. If flag is 0, it means that no need of changing the value. Okay. And now what is to be done? This thing is to be done. And after that, you need to shift the values, swap the values. So that part is this one. So you will be swapping the values, and this way, if this process is repeated n minus one number of times, you will get the sorted one. If we go to the last sorting algorithm, which is required in the case of sorting, is the merge sort. If you talk about the merge sort, then in that case, what we are doing, this is something which is known as the divide and conquer approach. Basically, we are trying to split the problem into smaller halves, and then when it reaches the lowest level or the simplest level, and then solve the problem and then rearrange it or combine it. So basically, it will have two parts. One part is known as the dividing part, this one, and other one is known as the merging part. So this part is division part and this part is merging part. Basically, what we do, we have one array. This is your array. We split this array into two halves. So one half is this one and one half is this one. This is level 1. Again at level 2, individual arrays are again split into two halves. So this one is divided into 2 and 2, and similarly these fours are divided into 2 and 2. So this is level 2 division. And at the level 3 division, what will happen? These two will be split into individual element, these two will be split into individual element, these two will be split into individual, and these two will be splitted into individual. So at this level, level 3, we are having individual element in each array. Now what is to be done? We start merging the values. So how it will be done? When you are merging, you have to take care that the lower value is on the left hand side. So compare these two values, and based on the comparison, you have to place the lower value on the left hand side and higher value on the right hand side. Similarly, it will be done for this, this, and this. Now it is important to understand that when you are having these two values, okay, when you have these two values and these two values, if you see, this is 7, 12, 18, and 22. In this case, it is in sorted order, so no problem. So you can directly take 7, 12, 18, and 22. But see this case. We are having 5, 16, 4, and 10. If you see, 4 is less than 5 and 16 as well. 10 is less than 16 but more than 5. So when you're combining these two, here you have to take care of this thing. So you need to compare these values as well while merging. So this may happen at any level. Even when you are combining these two as well, then also you see 7, 12, 18, 22. So 4 needs to be at this place. 5 also needs to be before 7. 10 is required to be inserted in between, and 16 is also required to be inserted in between. Right? I hope this thing is clear to everybody. What does this mean? So basically, what we are saying here is it is not compulsory while merging that all the values are in sorted order so you can directly place. Think from the programming point of view. If you are having two values, then you have to check whether they are in order or not. Then only you can store them at the proper place. Otherwise, you won't be able to store them at the proper place. Got it? So basically, in this case, you have to compare 4 with 7, 5 with 7. Okay, then 4 and 5 are smaller, so you will place them first, and then you will place 7. Then you will compare 7 and 10. Yes, 10 is larger, so 10 will come after 7. Before adding 10, you have to compare it with 12 also. Okay, 10 is smaller, so 10 will come here. Now 12 will be compared with 16. Yes, 12 is smaller, so 12 will come here. Now compare 16 with 22. So each step you have to do the comparison. I will repeat what I said. I will remove these lines first, then I will repeat what I said. What Naman is asking. Yes, I will tell you that thing as well. Wait. That thing is already considered in our algorithm. First of all, this concept should be clear to you. First of all, compare the first element of the first merging array with the first element of the second merging array. Which one is smaller? 4 is smaller. So 4 can be done here. Then compare 7 with the next element. 5 is smaller, so 5 will come here. Then compare 7 with the next element here, 10. Okay, 7 is smaller, so 7 will come here. Now compare 10 with the next element here, that is 12. Okay, so 12 will come here, and so on. I hope this thing is clear to everybody. Right? Now coming to the question somebody asked. Wait, it is taking a while to load. Here you see 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, and 8. So we have 9 elements. Then in that case, what will happen? We will find out 9 divided by 2, it gives me 4.5. So 4 have been considered here. So 0 to 4 will be considered here, and 5 to high. High is the last value, low is the minimum value, and mid is the mid value. So you will consider mid till mid over here, and mid plus 1 to high you will consider here, right?
It should be 0 to 3, no?
Sorry, 0 to 3, 3, 3, 3. Okay, and here 4 to 8 will be considered here. Okay, so this way we will go on identifying the values. Here also you can see when it is 5, then it is splitted into 2 and 3. Here also when it is 3, it is splitted into 1 and 2. And then further it is divided into 2 is divided to 1 and 1. Okay, while combining also it will happen that when you are combining here already 2 are there, 2 will be combined, then 3 will be combined as one array, then 5 will be combined as one array, and finally all the values will be combined. So here in this sorting algorithm, as you can see, wait, as you can see in this case that what it is doing, it is basically uh, distributing the values as individual numbers, and then based on the individual values it is merging them together, right? So this way merge sort is working. Let me open the code. Now if you remember what all things to be done in this case, first thing to be done is to divide them into subgroups, right? This is the first part. Till the point they are having single element. This is first part. Second part is start merging, right? And for merging, what is to be done? You have to find out greater than and smaller than values, right? Based on that, you will start on adding the values. So if you see the merge sort algorithm, this is the first part where we are identifying the mid values and the high values. Okay, so L1, L2 are the two labels, or rather, you can say arrays as well. Okay, so in this case, if you see, we have one array named AI, and where we will be storing the sorted values is B, right? So initially, what we are doing, we are taking the
Ma'am, screen
values.
is not visible.
Screen
I'm
is
screen
not
not visible.
visible.
Yes, ma'am.
Wait. What happened? Let me share it again. Yeah. Now is it visible?
Yes, ma'am.
Okay, fine. So basically here if you see, we are having the array A where some values are entered, and we want to use merge sort for doing this thing. And here we are having one function for merging. This is the function for merging, and this is the function for sorting. As I said, two things will be required. One is the sorting part and other one is the merging part. And this one here we are calling both the functions. If you see here, we are calling the sort function here, because for each case you will require sorting as well as merging, right? So here we are calling the sort function, and if you see the sort function here we are calling the merge function as well, right? If you see here, we are dividing them into using mid. Okay, so for one algorithm is from low to mid, other algorithm, sort algorithm, is from mid to high. And once you have sorted them, you are going to merge it using low, mid, and high, right? For each case. And how many times this thing will be repeated? This thing will be repeated n minus one number of times. If you see here, this is repeated from 0 to I is taken as max. Okay, I is less than equal to max, and where max should be, I think it should be n minus 1 or n. Max is taken as 10. Okay, 10 n minus 1 because n is 11, right? So here we are having n minus 1. So for each case, what we are doing, I will send you this code. You just go through this code, and then in the next class we will discuss this thing again, because this is a bit not complex, but a bit. It requires a number of modules to be run, so a bit lengthy, we can say, rather. Okay, so what we can do is, I will send you this code. You just go through it, what it is doing, and in the next class we will discuss merge sort once again, and the sorting algorithm is done for us, right? So searching and sorting is done. Now one topic was left earlier, that was recursion. So in the next class we will try to cover recursion, and then we will get the results. Then we will start with the structures. Sorry. Okay, so that's it for today. If you have any queries till this point, you ask, else we will close the meeting.
Sam, where you will share the code.
I will share it with your CR, and CR will convey it to you. Now only I will share it. Okay, anything else? Okay, fine. So I will close the meeting for today.